pause with the bands. Pause with the pause with the pause with the bands. Pause with the pause with the pause with the bands.
First, we would like to express our sincere gratitude to Allah Subhanahu Wa Taala for granting us the strength, knowledge, and opportunity to successfully complete this case study for MAT263 Linear Algebra 1. We would also like to extend our deepest appreciation to our lecturer, Dr. Hazwana Hashim, for her guidance, encouragement, and valuable insight throughout this assignment. Her dedication and support have greatly assisted us in understanding the application of linear algebra in solving real-world problems. Special thanks are given to the author of the article entitled Analysis of Solution of Linear System Using the Gaussian Elimination Method for Production Optimization in the Bakery Industry, namely Fitra Sari, Wahyuni Harahap, Ermayanti Astuti, Yulia Fitri, and Jen L. Nobreni, whose research provided valuable information and inspiration for our case study. Their work demonstrated the practical application of Gaussian elimination in optimizing production planning and resource allocation within the bakery industry. We would also like to acknowledge the reference and academic resources used in this case study, which helped us gain a better understanding of system of linear equation, metric operation, and Gaussian elimination method. These results have significantly contributed to the completion of our analysis and discussions. Finally, we would like to thank all group members for their cooperation, commitment, and hard work throughout the preparation of this project. The successful completion of this case study would not have been possible without the collective effort and dedication of every member. Thank you.
1.0 Introduction. The bakery industry often faces challenges in allocating limited raw materials across multiple products. Proper allocation ensures efficient use of resources and maximizes production output. Linear algebra provides a systematic way to solve this production planning problem by modeling resource usage as a system of linear equations. This case study demonstrates how linear algebra can support effective decision-making in bakery production management.
2.0 The purpose of the study. First, to determine the optimal production quantities of white bread, sweet bread, and cake based on the availability of raw materials such as flour, sugar, and eggs. Second, to analyze the solution obtained from the linear system and determine whether the system has a unique solution, infinitely many solutions, or no solution. Third, to demonstrate how linear algebra can support decision-making in production management by providing a systematic and quantitative approach to solving real-world industrial problems. Fourth, to demonstrate the application of Gaussian elimination in solving a system of linear equations related to production planning and resource allocation. Fifth, to identify feasible production combinations that maximize the utilization of available raw material without causing waste or shortage.
Next, I will explain the problem formation of our case study. In this study, a system of linear equation is formulated to represent the relationship between the production quantities of bakery products and the availability of raw materials. First, we define three decision variables. X represents the number of white bread units produced, Y represents the number of sweet bread units produced, and Z represents the number of cake units produced. Based on the amount of flour, sugar, and eggs required for each product, we obtain the three linear equations shown on the slide. Next, these equations are written in the form of AS equal to B, where matrix A contains the coefficients, matrix X represents the variables, and matrix B represents the total available resources. Then, we combine them into an augmented matrix. This matrix will be used to solve the system using the Gaussian elimination method. After obtaining the augmented matrix, we apply the Gaussian elimination method by using elementary row operations, or ERO. First, we interchange the first and third rows so that the pivot element becomes 1. This makes the elimination process easier. Next, we perform row operations to eliminate the value below the pivot. Then, we simplify the second row by dividing it by 10 and continue the elimination process until the matrix reaches row echelon form. Finally, after performing the last row operation, we obtain the final matrix shown at the bottom of the slide. This matrix will be used to determine the solution of the system.
Solution method. The system is solved using metric method, that is AX is equal to B, and Gaussian elimination, which includes: first, define the variable representing the production quantity of white bread, sweet bread, and cake. Second, formulating the system of linear equation based on the usage of flour, sugar, and eggs. Third, representing the equation in a geometric form. Fourth, applying elementary row operation to transform the argument matrix into row echelon form. Fifth, performing Gaussian elimination to eliminate variables systematically and simplify the matrix. Sixth, using back substitution to determine the value of x, y, and z. 7. Obtaining the general solution and determine whether the system has a unique solution, infinitely many solutions, or no solution. 8. Selecting a realistic production combination that satisfies all resource constraints and ensure efficient utilization of raw material. And lastly, interpreting the result in the context of production, optimization, and decision making in the bakery industry.
Now, I will present the result obtained from the Gaussian elimination process. From the final row echelon matrix, we obtain the equations x plus 2y plus 3z equal to 140 and y plus 2z equal to 70. Since the third row consists entirely of zeros, the system has a free variable. Therefore, following the method that we learned in class, we let z equal to t. By substituting z equal to t into the equation y plus 2z equal to 70, we get y equal to negative 2t plus 70. Next, we substitute both y and z into the first equation, x plus 2y plus 3z equal to 140, and we obtain s equal to t. Therefore, the general solution of the system is s equal to t, y equal to negative 2t plus 70, and z equal to t. To obtain one practical production combination, we choose t equal to 20. After substituting this value, we get s equal to 20, y equal to 30, and z equal to 20. So, one suitable production plan is to produce 20 units of white bread, 30 units of sweet bread, and 20 units of cake.
4.2 Discussion. First, the system has infinitely many solutions after Gaussian elimination. Second, different production combinations can use all four, sugar and eggs without waste. Third, this allows flexible production planning, making the chosen mix practical and realistic. The last one, linear algebra helps optimize resource allocation and decision making.
In conclusion, this case study demonstrates how the Gaussian elimination method can be applied to solve a real-world production planning problem in the bakery industry by representing the production constraints as a system of linear equations and solving them systematically. An appropriate production combination can be determined. The final production combination of 20 units of white bread, 30 units of sweet bread, and 20 units of cake satisfies all the given constraints while making full use of the available raw materials. Therefore, this study highlights that the application of linear algebra can help improve production planning and support effective decision-making in real-world business operations.